Patapsco is a Python framework for running cross-language information retrieval experiments. In cross-language information retrieval, the queries and the documents are in different languages. For example, you may have a collection of German documents, but want to express your query in English. Patapsco uses the retrieve and re-rank approach of modern IR research tools, as shown in this diagram. First, the documents are normalized, which could include tokenization, stopword removal, and stemming. Then an inverted index is built using Lucene. The queries are processed in a similar language-specific way, and this could include machine translation or other methods of projecting the queries into the language of the documents. The top documents are retrieved from the index, and then finally, the documents can be re-ranked using a neural re-ranker model that could use bilingual embeddings. Patapsco is a configuration-driven pipeline. Here I'm showing a configuration for a Russian experiment. And to run the experiment, you run the Patapsco command line tool and then pass in the path to your configuration file, which is a YAML file, which will then start your experiment. The experiment is completely described with this YAML file. We describe where the documents are located, what language they're in, and what sort of processing we want done to the documents. And so here I'm specifying that I want the text to be lowercased. I'm going to use a particular kind of tokenization and stop words and so forth. We do the same thing with the topics and the queries. So for the topics, I specify here that I want the fields to be both the title and the description from the topic, that these are English topics, and then I specify what sort of processing I want of the query. And this is going to include here using a method to project from the English queries into the Russian documents called probabilistic structured queries that uses a translation table, and that translation table, the path to it is specified here. That's going to allow us to do retrieval. We're going to retrieve using BM25, and then we're going to specify that we want 1,000 documents to be pulled back. In addition, we could have a re-ranker here that would use those 1,000 documents and re-rank according to some other metric or model. And then finally we go into scoring, where we pull back the QRELs and compute the metrics that are specified in this file. And then you can see here at the end of my experiment, we've run through and we've built the Lucene index. We have processed the queries, done retrieval, and it comes back and tells us how long it took. It tells us how the performance measured by these different metrics and memory usage. When a run completes, it creates a directory with all of the artifacts used to build that run. Those artifacts can be reused for future runs. So if you have a large collection and you want to build a single Lucene index and then perform lots of experiments off of that index, you can do that. If you want to do the retrieval first, and once you have the retrieval of your top 1,000 documents per query, or 10,000 documents, or whatever number you prefer, you can then save out those particular documents into our document format, and then rerun experiments on just re-ranking again and again. In the directory from the run, we save the configuration file, which makes it easy then to rerun that exact configuration to be able to reproduce that result. We also, of course, store the log files so you can see if any errors occurred, the results that could be fed into any sort of scoring routine, and the scores per query. And the reason we store the scores per query here is that it allows us to run different kinds of visualization tools to see what our performance looks like across the queries, to see if there are particular queries that we want to look at more and try to understand where we're performing well and not. Finally, we also store timing information for every single component that runs in the system. So from an engineering perspective, if you wanted to improve the performance of your retrieval system or your document processing, you can go into this section here to understand where all the time is being spent on your system. The demonstration I did for you just now was a single-threaded demonstration on a Russian collection of about 16,000 documents. We have run Patapsco on larger collections up into the millions of documents. It is built so it can run single-threaded. It is built so that it can also run with multiprocessing for as many cores as you have on your laptop. And then finally, we have put a lot of work engineering in a system that allows us to use grid computing. So for very large collections where you may have an expensive text processing component, we can use things like Slurm or QSub to run lots of jobs to split up the collection to build that index. And that is all built directly into Patapsco. So that all you would have to do to run one of those is go back up to your configuration, add a new section to your run to say that you want this to be a parallel run, and that the type of the run might be a QSub. And then you would also then specify the particular queue that you're using. And Patapsco will generate the scripts necessary to run that and schedule all of your jobs, and optionally send you an email when those jobs are complete so that you can take a look at your results. So this is Patapsco. It's a Python framework for doing cross-language information retrieval. It is built on Pyserini, which is a commonly used framework for doing monolingual. And then it provides lots of extra benefits in terms of processing for lots of languages and being able to extend your work into parallel environments.